Hey guys, welcome to Conceptual Geometry, Unit 4, Day 11 work session. This video I'm going to work out the solutions to answer any questions that you might have as you're completing the work session. Question number 1, it says the image of the point 3, negative 6 when reflected in the y-axis is. So I am going to assume that you have your study guide as you do this, and a reflection in the y-axis you're going to note on the study guide is negative x, y. So when you reflect in the y, you actually negate the x. So what you would do is you'd take a look at this point here, and you have to negate the x. So it becomes negative 3, negative 6. That would be choice 2. Question 2, which of the following transformations is a reflection in the origin? So once again, look at your study guide, reflection in the origin, you negate both. So we have to take a look to see which one of these illustrates negating both. Well, that one's not negated, so it's not choice 1. 4, 2, negative 4, negative 2. Yeah, that negates both. So this one would also be choice 2. And just very quickly, we'd rule out the other ones. Did we negate both there? Nope. Do we negate both there? No. So it's not either one of those. Question 3. Which figures, if any, have both point symmetry and line symmetry? Well, a quick glance shows us that all of these have line symmetry. So the issue is going to be which ones have point symmetry. Point symmetry, if you remember, is if you turn the shape upside down, is it the same shape? This one, yes. This one, I think, is pretty obvious. Also, yes. This one here is no, and the reason for that is this point would be down here, so it kind of looks something like this, right? I'm just kind of estimating this. So it would not be the same. That does not have point symmetry, so we're looking at A and C only. Choice 1. Question 4, in which quadrant does the image of 4, negative 7 lie after reflection in the origin? So this one, what we're going to do is make a quick sketch. First of all, 4, negative 7 would be down here. And then if we reflect through the origin, that point travels through the origin, ends up there. Well, remember your quadrants. This is 1, that's 2, that's 3, and that's 4. So clearly we end up in quadrant 2. All right, question 5, which of the following shapes does not have point symmetry? So up above, we talked about point symmetry. Is it the same upside down? Well, let's check out a square. Yeah, same upside down. Parallelogram, make a sketch, rotate it upside down, and it's exactly the same. Pentagon, you need to remember, is a 5-sided shape. So if we rotate that upside down, the point is going to be down here, so that does not have point symmetry. And the letter S, believe it or not, does, because if you turn an S upside down, it's still an S. Okay, moving on. Question 6, draw an isosceles triangle and draw all lines of symmetry. So an isosceles triangle is like a capital A, and you connect the base. Now, there's only one line of symmetry for an isosceles triangle, and it's right down the middle vertically, like so. That's all you have to do for that question. Number 7 says find the image of the point, negative 2, 6, after reflection in the line y equals negative x. So again, look at your summary sheet. The rule for reflecting the line y equals negative x is you switch and negate both. So it's negative y, negative x. So the way we apply it, number 1, you switch. And then number 2, you negate. So it ends up being negative 6, 2. Not a lot of work to show if you apply that rule, but make sure you come up with that point. Question 8, what are the coordinates of the point negative 1, 5 when reflected in the line x equals 3? So the first thing we'll do is sketch that point, negative 1, 5. Negative 1, 1, 2, 3, 4, 5. So plot that point right there. And then remember, the line x equals 3 crosses the x-axis at 3. So it's cross the x-axis at 3. It's this line right here. There's your line x equals 3. So to reflect in that line, you have to count the number of spaces to that line and then go the same number to the other side. So that point's going to end up right there. coordinates of that point. Remember, here's your origin. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7, 5. Number 9 will be a little bit challenging. It wants you to sketch the image of triangle QRS under a point reflection in point X. Label the image Q prime, R prime, S prime. So it doesn't have to be exact, but the way this works is if I start with point S and I want to reflect it through X, is you draw a dashed line and then you estimate the same distance to the other side and put the image there. So that would be S prime. I do the same thing with Q. Straight line to the point and then estimate the same distance to the other side. Looks like about there. That'd be Q prime. R looks like it'll be a little bit more challenging. And then to the other side, about the same distance. And there's R prime. And then all you have to do is connect those. Okay. Next question, 10. All right, so it says graph triangle ABC with vertices A is 3, 1. So I'll do this one at a time. A is 3, 1. Let's plot that point first. Okay, so there's A. B is 4, 3. 1, 2, 3, 4. 1, 2, 3. There's B. And C is negative 1, 2. That's over here. There's C. And let's connect those. It says, then graph and state the coordinates of the vertices of triangle A prime, B prime, C prime, the image of triangle ABC after a reflection in the y-axis. All right, well, here's your y-axis. So what's going to happen is C is actually going to go over here, A will go over here, and B will go over there. So we can be visual. We can also use our rule. Remember, reflecting in the y-axis, you negate the x, negative xy. So you could take a look at these coordinates and come up with those first. So we can do A prime, B prime, C prime. If I wanted to use the rule, I would rewrite these coordinates and negate the x in each one. Okay, so A prime will be negative 3, 1. B prime would be negative 4, 3. C prime would be 1, 2. When you negate a negative, it becomes positive. And then you could plot those points. Or, remember, what you could do is you could be visual. So point C would just go here. Now those coordinates happen to be 1, 2, which is what we got using the rule. So I don't care which method you use, but you have to come up with the drawing and the coordinates. All right, so A would be over here, A prime rather, negative 3, 1, and B prime would be negative 4, 3. And then sketch in that triangle. So it's always a little tricky when the line of reflection goes through your shape because part of it goes to the other side. Question 11, the coordinates of the vertices of triangle ABC are A is 0, 2. So once again, I'll plot these one at a time. So A is 0, 2, right there. B is negative 2, negative 4, it's down here. And C is 4, 6. So 4, 6. This triangle will be a little bit challenging to sketch in. All right, it's kind of far apart. Let me see if I can do this somewhat neatly. Okay, now it says graph and state the coordinates of A prime, B prime, C prime, the image of triangle ABC after the translation T, negative 2, 3. So there's a couple ways you can apply this. Remember, the first number is right or left. If it's negative, that means left. The second number is up or down. If it's positive, that means up. So I could take each one of these coordinates and go left 2, up 3, and then write my new point there. So that might be easier for some of you. Let's do it that way. Point A, go left 2, up 3, and A prime goes here. Do the same thing for C. Left 2, up 3, and then there's C prime. And then B, left 2, up 3, there's B prime. Okay, and then what we would do is connect those. Now we still need to come up with those coordinates for A prime, B prime, and C prime. So if you were a visual person and you did this sketch first, then you would just look at the coordinates and write those down. If you're more of an algebraic person, what you would do is you would take this -2 and you would add it to all of those x values there. And then you would take this +3 and you would add that to all of those y values. But it should check no matter which way you do it. All right, so point A prime, no matter which way you do that, ends up being -2, 5. B prime ends up being -4, 1, and C prime ends up being 2, 9. Okay, the last one, it says graph and state the coordinates of triangle A double prime, B double prime, C double prime, the image of, now it's important, ABC. So we're going back to the original. We're using this one. Okay, and after a dilation of 1/2. So the way this is going to work is we have to apply our rule for dilations. This is too hard to do visually. Remember what a dilation of 1/2 does. That means you're going to multiply the coordinates by 1/2. So I'll go back to the original coordinates right here, and I'll take each one of those and multiply it by 1/2. Same thing with this, same thing with that. Okay, so A double prime will be 0,2 times 1/2. So that'd be 0,1. B double prime will be -2, -4 times 1/2. That becomes -1, -2. And C double prime is 4, 6 times 1/2. So that becomes 2, 3. And then I would graph that triangle. So A double prime is 0, 1. There's A double prime. B double prime is -1, -2. So right there is B double prime. C double prime is 2, 3. And then I'll connect those sides. Question 12. State the transformation that took place. Use a translation as a last resort. If you've got your study guide, that'll come in very handy here. What you want to do is look at the coordinates to see what changed. So if you notice, you go from 2, -7 to -7, 2. I changed the order. When you change the order, that is a reflection in the line y equals x. The next one, 4, -6, became 6, 4. So not only did I change the order, but this one was negated, because notice it's positive here but negative there. So this rule is -yx, and if you look at your study guide, that is a rotation of 90 degrees. Letter C, 3, 5 became -3, -5, so I didn't do any switching, I just negated both. This is kind of interesting because you have two options. One option is a reflection in the origin, or you can say a rotation of 180, because remember, there are two transformations that are identical. The reflection in the origin is the same as rotating 180. Now, you don't have to mention both. You would just either list this one or this one. All right, letter D. -1, 5 became 3, 15. So notice the numbers are completely different. What happened? It looks like I multiplied by -3, right? Because a positive became a negative in both cases. So when you multiply, that is a dilation. So this would be a dilation, and the scale factor is -3. Letter E, 6, 2 became -2, -6. So we changed the order, and we negated both. That is a reflection in the line y equals -x. Now this one is when the numbers just go completely different. Obviously, you didn't multiply by anything. This is a translation. That's why it says use a translation as a last resort. So what you have to do is you have to figure out, all right, it's a translation. The first number here is what you had to add to go from a -5 to a 3. So I had to add 8. So that means your first number down here is an 8. The second number is going to be what you had to add to 7 to make it 0. We added -7. So that means this number here is a -7. Letter G, 4, negative 6 became 4, 6. The only thing that changed is this. You negated the y. This is x, negative y. If you look at your study guide, that is a reflection in the x-axis. And the last one here, negative 7, negative 3 became 7, negative 3. So what changed is the 7. You negated the first one. That's negative xy. Negate the x. That is a reflection in the y-axis. All right, our last one. It says, given the points A is 1, 1, B is 4, 1, C is 2, 5, graph triangle ABC. All right, so I'll do this one at a time. I have to scroll a little bit here. So A is 1, 1. Let me plot that. There's point A. B is 4, 1. So there's point B. And C is 2, 5. So there's C. And then I'll sketch that in real quick. All right, so now it says graph and state the coordinates of triangle A prime, B prime, C prime, the image of triangle ABC after a rotation of 90. So a rotation of 90, I'm going to jot down the rule here. This is too hard to do visually. If you look at your study guide, the rule for rotating 90 is negative yx. So I will use these coordinates and apply this rule, and I'll list the new coordinates first. A prime. So switch these and negate the first one. That's negative 1, 1. B prime. Switch these and negate the first one. It's negative 1, 4. C prime. Switch these and negate the first one. That's negative 5, 2. And then what I'll do is I'll plot those coordinates. Okay, so let me do that. A prime is negative 1, 1. It's right here. B prime is negative 1, 4. So that goes right there. And C prime is negative 5, 2. It goes right there. And then we'll just connect those. All right, and the last part, graph and state the coordinates of, now again, this is important, A double prime, B double prime, C double prime, which is the image of A prime, B prime, C prime. So I'm using this triangle here and these coordinates here. After a rotation of 180. So rotation of 180 is you negate both coordinates. So I think the easiest way to do this is to take a look at your A prime, B prime, C prime coordinates and just negate both in each case. It's pretty quick to do. So A double prime becomes 1, negative 1. B double prime becomes 1, negative 4. And C double prime becomes 5, negative 2. Then what I'll do is I'll plot these on the grid down below. Okay, so I have to scroll up a little bit. So A double prime is 1, negative 1 right here. B double prime is 1, negative 4. That's here. And C double prime is 5, negative 2. That goes there. And then just connect those. All right. So that concludes the virtual key, if you will, solution guide to work session day 11. You'll have another work session to do tomorrow, and then the unit review we'll be testing next week. Please reach out if you have any questions whatsoever. Thanks for watching and have a great day.